So I started at Atlassian in February, and after boot camp, I went onto the JIRA team. I was on the JIRA team for about 3 weeks working on reloadable plugins. Who here likes reloadable plugins? Yeah! Get excited! I think the hangovers are kind of kicking in a bit. But, so I was working on reloadable plugins, and I thought this plugin system is kind of cool, you know. You could do all sorts of cool stuff. There's web resource transformers, there's serverless, there's everything that I could ever think of. And I was thinking, well, what kind of problems would plugin developers ever have with all this rich functionality at their fingertips? And then I got tapped on the shoulder and asked to join the Bonfire team. And now I know. I'm in your shoes, developing plugins full-time, and know your pain. So today, I'll be talking about a few things about Bonfire and how we did it. So to start off, I'll be talking about what Bonfire is and just a brief overview of Bonfire. I'll then jump into how to build plugins for multiple JIRA versions. So Bonfire, when it initially shipped, supported JIRA 4.2, 4.3, and 4.4. And at the moment, we're supporting 4.3, 4.4, and JIRA 5.0 at the same time. So there's a number of challenges involved in supporting multiple JIRA versions, and I'll run you through some of the problems and solutions for those to those problems. I'll then jump into talking about JIRA integration within Bonfire and some of the problems we faced building a JIRA client that existed outside of JIRA, and some of the solutions to those problems that we had. So what is Bonfire? Bonfire is a tool for exploratory testing of web applications. It consists of a browser extension targeting multiple browsers, Internet Explorer, Safari, Firefox, and Chrome, as well as a JIRA plugin, which targets multiple JIRA versions. So as you can imagine, we have this large testing matrix to be able to deal with between the multiple browser extensions and the multiple JIRA versions. So within Bonfire, the browser extension, it is a full-featured JIRA issue creation client. So you can submit bug reports directly from your browser and directly within the context of your web application, straight into JIRA, including all the context that you've gathered within your web application. And on the JIRA plugin side, we've got a number of features to help you track and manage your testing activities. So test sessions and session notes are the main two new entities for tracking your testing activities. And if you'd like to find out more about Bonfire, the link is up at atlassian.com/bonfire. You can download it today and get a free 30-day evaluation. But I'm not here to sell you Bonfire. I'm here to talk about how we built Bonfire. So how did we build a JIRA plugin that can target multiple JIRA versions? Firstly, I'll be talking about why you should be targeting multiple JIRA versions. So we decided to target 3 JIRA versions. I'd like to talk to you about why we made that decision and why you should be targeting multiple JIRA versions as well. I'll then talk about some of the problems that we faced building a JIRA plugin that supported more than one version of JIRA, and some solutions to those problems that we faced. So one of the main, actually, I'll just take a quick poll. Who here is building JIRA plugins? It's a fair number of you. Now, of you, who are doing internal plugins, so plugins just for within your company? It's probably about half. And then who is doing commercial plugins, so plugins outside? So it's about a 50-50 split. Hopefully I can give you some reasons for both internal and commercial developers as to why you should be targeting multiple JIRA versions. So as a commercial developer, the main reason why you should be building a JIRA plugin that targets more than one JIRA version is to maximize your customer base. So as you can see here, I've got some slightly old data from when JIRA 4.3, just a little bit after JIRA 4.3 was released, we did a customer survey. As you can see, there was a number of early adopters who jumped onto JIRA 4.3. However, there's still actually twice as many people on JIRA 4.2 and even more on JIRA 4.1. So the JIRA 4.1 people were already one version behind when 4.2 was out, and then when 4.3 was out, they still hadn't upgraded. So you don't want to be cutting out this large amount of your customer base just by targeting the latest and greatest JIRA version. You want to be able to support these older JIRA versions such that you'll have a larger customer base to be able to target for your marketing. Now, as an internal developer, you may face a problem having multiple JIRA instances. Within Atlassian, we've got, for example, support.atlassian.com and jira.atlassian.com, which are on different JIRA versions because support.atlassian.com requires a more stable bug fix version of JIRA, whereas jira.atlassian.com is on a latest and greatest version of JIRA. So if you want to deploy your plugin to more than one instance internally, being able to support multiple JIRA versions really helps if the release cadence for each instance isn't the same. And for both internal and external, supporting multiple JIRA versions means that you can be ready for upgrades. So you can today test against early access previews of both JIRA and Confluence and give us feedback as to what breaks within your plugin and whether or not that is an expected breakage in the documentation or whether this is a new breakage that we may not know about. And the other positive of building against the APIs is that you can help participate in building the APIs because we build out the APIs based on internal customers such as Bonfire and Grunert and what needs that they have, but you may have different needs. For example, Matt Dorr might want new administration plugin points in the REST APIs, but Grunert and Bonfire, for example, won't ever hit that. So if you can test against the APIs, you can give us that feedback. Plus, with JIRA 5 coming out soon, if you release with JIRA 5 on November 30, you'll be participating in our marketing campaign and you'll get a major boost. So you kind of want to be doing this. So what are the problems that you may face trying to build a JIRA plugin that supports more than one version of JIRA? So one of the biggest problems is Java API changes. I'm sure you will hit this, particularly with the JIRA 5 release where we're overhauling the Java API. Trying to deal with those breakages between the APIs is really challenging. JavaScript and Markup changes are another problem, particularly because the DOM is not a very stable API within Atlassian. It changes quite a lot, and if you want to be targeting multiple JIRA versions, this is something that is likely to bite you. And the third main problem is testing. So once you have built a plugin that is able to target more than one JIRA version, you want to be able to run automated tests across each of the JIRA versions that you're targeting, such that you can get some benefits out of continuous integration. So the way I see it, there's two major strategies to building a JIRA plugin that supports more than one JIRA version. The first of them is branching within your version control system. So the advantage of branching within your version control system, like Mercurial, is that your code is cleaner. Because you don't have to deal with the breakages within your code and it's dealt with within the version control system, your code no longer has to be, doesn't have to be cluttered up with if it is this JIRA version, then do this thing, otherwise do this thing. So you get some cleaner code. But is this good or bad? So if you do multiple branches, you kind of want to know whether, when you are going to be touching a piece of functionality that does have differences between JIRA versions. So having it in your face in the code may be a good thing in terms of not changing some code and then having merge pain later. And one of the big disadvantages with multiple builds is just the amount of overhead that it incurs in your development process. So there's overhead in builds, being able to build across each of the branches for each of your JIRA versions. There's overhead in merging, so when you build some functionality targeting one version of JIRA, you then have to try and merge them across each of your branches and fix up any of the breakages that may have occurred when you've made those changes. And testing is also a pain because you end up having to deploy multiple jars for starters, and then test across each of those jars. So you end up having to check out a different branch and then, or switch to a different branch and then rebuild your plugin and then deploy it to a new version of JIRA and then do your testing. Another thing that's not listed on this slide is customer pain. So if you do take the approach of branching, you end up having to ship multiple jars. So you'll ship, say, one jar for your JIRA 4.4 customers, and then one jar for your JIRA 5.0 customers. And there's confusion there as to which jar do they have to download and install to get the plugin up and going on their system. So the second approach would be to have one build, so one branch, and target multiple JIRA versions. So just a quick show of hands between the two approaches. If you are you targeting multiple JIRA versions? Is anyone targeting multiple JIRA versions? Now, who here branches to be able to support this? 3. And for not branching, 1 build? Just a couple. Okay. So one disadvantage of the one build multiple versions is that your code is messier. So you have to deal with all these breakages within the code itself instead of dealing with it within branches. But there are significant advantages in the lack of overhead that is incurred. So there's no merging between different branches. You're shipping one jar. When there are code changes that have to be done between JIRA versions, it's in your face. All your tests are in a single branch, and yeah, you know when you're touching the problem areas. So I'm advocating the one build targeting multiple versions approach, and this is the approach that Bonfire and Speakeasy have both taken. So I'll now run through 6 techniques to be able to build JIRA plugins that target multiple versions without branching. So the first will be doing continuous integration across those multiple versions using AMPs. Secondly, I'll talk about JavaScript and Markup changes and handling those using AJS.version. Thirdly, I'll talk about non-compile time breaking API changes and handling those using build utils info in JIRA. Fourth, I'll talk about UI location changes and dealing with those using Web-fragment Conditions in addition to build utils info. Fifth, I'll talk about compile time breaking changes and how we can deal with some of those using reflection. And sixth, I'll talk about how you can deal with those compile time breaking changes in a more large-scale way with dynamic module types. So, continuous integration. It's great. Everyone here uses Bamboo, right? Yes? Woo! Get excited. So, with continuous integration on targeting multiple JIRA versions, we can use AMPs and the test groups functionality in order to build and run our tests for our JIRA plugin across multiple JIRA versions within our continuous integration system. This is really excellent for quickly identifying compile time breaking issues, as well as some of the issues that we can find during our testing for the multiple JIRA versions. We'll just run you through some ES-XML. So you can see here that we're using the Maven JIRA plugin, and we're just setting up 2 products. One of them is JIRA 4.3, and the second one is JIRA 4.4. And once we've configured those 2 products, we can then set up 2 test groups. One of them is to run all of our tests on the JIRA 4.3 product, and the other is to run all of our tests on the JIRA 4.4 product. It's very straightforward. The documentation is online on developer.atlassian.com, and this will really help you to be able to run your continuous integration across multiple JIRA versions. So now that we've got our continuous integration running, we want to be able to deal with some of these JavaScript and Markup changes that happen between JIRA versions. So the most straightforward way that I've found to be able to deal with these is to use AJS.version in order to query the version of JIRA and split the code path based on the version returned. So another great resource is the AUI version matrix on developer.atlassian.com. And this here will list the AUI version for each product for each version. And this way you'll be able to find out, okay, if I'm targeting JIRA 4.3, it's got this AUI version. If 4.4, then this other AUI version. So you can see here, I've just on support.atlassian.com, and I'm querying AJS.version. I'm getting 3.3.1 back. Whereas on jira.atlassian.com, I'm getting 3.4.2 back. So you can see that it's quite easy to then just build an if statement to be able to switch the code path based on this AJS.version. So now we've dealt with our JavaScript and Markup changes, and we want to be able to deal with non-compile time breaking changes in the Java APIs. So within JIRA, there's a class called build-utils-info, which can be used to be able to find out the version of JIRA and split the code path based on that. So as you can see here, we're just splitting the code path based on whether or not it is 4.3 and putting in some 4.3 specific code. Otherwise, anything beyond 4.3 goes in the bottom block. And this is used within Bonfire to be able to handle the changes in the custom fields API between 4.3 and 4.4, with the new custom fields API having separate IDs and names for custom fields. So now we've got build-utils-info, and we can query the JIRA version within Java. We can now use this in addition with Web-fragment Conditions to be able to change where web items and web fragments show up in the UI based on the JIRA version. So there is a Web-fragment condition online called is prior to JIRA version to be able to show web fragments only on certain versions of JIRA. And this is used within Bonfire for handling the JIRA 4.4 administration menu changes and changing where the web items for the Bonfire license show up, whether it's on the side in the massive long list of links or up the top in the nice top nav. So as you can see here, we've got the old admin link web section showing up in the system admin location using the condition is prior to JIRA version with version 4.4. So these are all small scale changes, but what about large scale changes to the Java APIs? So one approach to dealing with large scale changes to the Java APIs, which will break your compile time, is to use reflection. So who here has used reflection in the past to be able to deal with these changes? A few people. So it's used mostly to load a class that's only present in later versions of JIRA, or to load a class that changes names across JIRA versions. And this is used within Bonfire for dealing with the time zone manager, which only exists within JIRA 4.4, and in JIRA 4.3 and 4.2 it wasn't present because JIRA 9 had yet to be resolved. So here's an example from Bonfire's code where we're loading in the time zone manager and getting out the get logged in user time zone method and invoking that to be able to find out the user's time zone. And as you can see, this could throw a large number of exceptions, so we then shows exception and return the default time zone for the system if the user time zone isn't present. And of course, we can also clean this code up and make it slightly more performant by using build-utils-info beforehand to only try and load in the class using reflection if we are in JIRA 4.4 or later. So this is all well and good, and loading in a single class using reflection is quite easy, but how does this all look in JIRA 5.0? So in JIRA 5.0, OpenSymphony user has been removed entirely. So because in JIRA 4.3, a new feature was introduced to allow for LDAP groups to be used within JIRA. And to do this, we use some of our existing product crowd to be able and translated that into JIRA to be able to perform this functionality. But at the time, we didn't remove OpenSymphony users because we didn't want to break a large number of plugins. But with JIRA 5.0, it's given us the opportunity to remove OpenSymphony user and move entirely to embedded crowd user. And because of this, there's some large-scale compile time breaking changes. So even though there are a number of ways to get out embedded crowd users instead of OpenSymphony users, there are certain plugin points which will pass you an OpenSymphony user, and there's no way to get around that to be able to not get it to pass you a OpenSymphony user. And if you try and use those plugin points across JIRA 4 and JIRA 5, the JIRA 5 compile time will break as the OpenSymphony user is no longer present. So how did Bonfire deal with this? At first, we looked at this problem and decided it was a very, very large problem to try and solve just using reflection, and we'd have to use reams and reams of code. So we tried branching. So we dropped 4.2 support, removed as much OS user as possible by using the get logged in user object or the other nice methods which returned you an embedded crowd user. But as I said, there's some instances that we just couldn't remove. And at that point, we then created a branch to be able to support JIRA 5.0. One thing that we did hit whilst we did this was that there was a number of pains with deprecation. So in JIRA 4.3 and 4.4, the new methods introduced, such as get logged in user, to be able to return the embedded crowd user, were the favored methods to be able to get user objects, which is obvious because we knew that we were removing Open Symphony user as soon as JIRA 5.0 came out. But in the process, we then deprecated the older methods, such as get user. But then when we moved to JIRA 5.0, we switched around and deprecated the newer style methods, such as get logged in user, in favor of the better named methods, such as get user. So that means that if in JIRA 4.3 and 4.4 you tried to do the right thing and reduce the number of compile time warnings that you would get using deprecated methods, you would then move to JIRA 5.0 and get a large ream of compile time warnings because you're using deprecated methods now. So we did this process, we did the branch, we were working on it for a few weeks, and we found that branching just sucks. For the same reasons that I outlined before. There was no eyes on the JIRA 5.0 changes. There was a lot of merge pain, so once we'd finished some work that we were doing in JIRA 4.4, for example, we'd then have to merge that work back into JIRA 5.0, and that was a largely manual process because every so often there would be merge conflicts. We had to ship multiple jars, so we were shipping a jar for JIRA 4 versions and then another jar for JIRA 5 versions. And we looked at this and it was not great. So how can we fix this? So someone smarter than us came up with a solution for us and created a compatibility library. That was Don Brown, who created it for Speakeasy to be able to support JIRA 4.3 to 5.0 without branching. And this used dynamic plugin module types to allow for new cross-version compatible module types to be injected into JIRA. So these module types would be analogous to the existing module types that we're using, such as issue tab panel and project tab panel. But instead of passing in an Open Symphony user to us, it would pass in the embedded crowd user such that it would work across JIRA 4.4 and JIRA 5.0. So this sounds magical, but it's also very complicated. So how does it do it underneath the hood? There's 4 Maven modules being compiled, and 2 of those Maven modules are being compiled against different JIRA versions. So one is being compiled against JIRA 4 versions, and one is being compiled against JIRA 5. And there's a factory being Spring component, try saying that 10 times fast, to inject the correct dependency based on the JIRA version. So if it is prior to JIRA 4.4, it will inject the dependency from the JIRA 4 compiled Maven module. Otherwise, it will inject the dependency from the JIRA 5 compiled Maven module. So if you're interested in this work, let me know after the talk. I'm hoping to open it up such that other people can get at and use this same method. Otherwise, it is possible, is what I'm trying to say. So some takeaways from Bonfire's multi-version supporting experiences. So the first takeaway is that you should be doing multi-version support. If nothing else, to be ready for upgrades between, for example, JIRA 4.4 and 5.0. If you start supporting JIRA 5.0 before it is released to customers, it means that you will be able to support JIRA 5.0 on launch. And this is a massive win for you in terms of being able to do a marketing push with JIRA 5.0, as well as making sure that if you're an internal developer, there's nothing blocking you from upgrading to the latest and greatest version of JIRA when it is released. The second takeaway is that you don't have to branch to do multi-version support. So I personally advocate not branching to do multi-version support. Your mileage may vary, but the pains involved of dealing with merging, dealing with the build overhead, dealing with releases, dealing with the extra testing, it's not worth it compared to the wins you get if you get it all into one branch. And the third major takeaway is that the documentation can help. And I believe this is an old link, but developer.atlassian.com should have links for plugin developer notes for each of the JIRA versions. And these will outline the things that are likely to break between JIRA versions for your plugin. And reading these is an excellent resource for working out what problems you may face when you do try and support more than one JIRA version. Now I'll move into the second part of my talk, talking about the JIRA integration within Bonfire, between the Bonfire browser extensions and JIRA. So how we went about this, some of the problems that we faced, and some of the solutions to those problems. So the three main steps that we had to go through to be able to create a client within JIRA, external to JIRA, which was able to create issues within JIRA. The first was to be able to authenticate with JIRA such that the user didn't have to first go to JIRA and log in before coming back out to be able to create their issues. Secondly, was querying JIRA to be able to find out the metadata related to issues. So to be able to pull out from the system the projects, the issue types, and all the fields for that system such that we can render the create issue form outside of JIRA. And third is actually creating the issue. So once we've rendered the issue form, the users filled out their information, being able to send that information across to JIRA and create the issue. So one of the main problems, some of the problems that we faced doing authentication within Bonfire, the first was that we couldn't store the password. So the naive approach would be to store the username and password and do basic authentication on every single request. But we didn't see this as a good approach within browser extensions, as the only storage mechanism that we had available to us was local storage, and we don't see that as a viable and safe location for us to store user passwords. The other problem we faced was being able to do a single-step authentication such that we could authenticate once and then continue to work with multiple different APIs within JIRA. So to do this, we use JIRA's REST API to be able to authenticate with JIRA, and this returns us a cookie. So we did do a basic auth request with the username and password that the user fills out, get a cookie back, and we continue to use that cookie for all future requests. And then if there is a timer on that cookie, we then re-authenticate. So now we've authenticated with JIRA, and we want to pull out some metadata, all the metadata associated with that JIRA instance, to be able to draw this create issue form. So our first approach was to use XML RPC to be able to pull out this information. But we faced a number of problems with the XML RPC API. There were some fields missing, such as the security level field and a number of others. And this meant that we weren't getting all the information out that we needed to render the full create issue form. And if the customer had those fields as required fields on their JIRA instance, we were unable to create an issue on that JIRA instance as we weren't giving them the option to fill out that information and send it off. So how did we deal with this? Unfortunately, we can't use REST to be able to pull this information out because it's not present in JIRA 4.3 and JIRA 4.4. So we moved to our own custom solution. The bad points about this is it's more code for us to write to be able to get things up and going. It's also more code for us to have to support. But on the good side, we are in control of this resource, so we can make sure that it works on every instance that we're trying to target. We can also add Bonfire-specific features to this resource. So one example of this was previously, when we were rendering the create issue form, we would query JIRA for the projects and then get a selected project, and for that project we'd query JIRA for the issue types and then get a selected issue type and then do a third request to JIRA to be able to pull out the fields. So that was 3 requests just to be able to fill out this create issue form. This wasn't great. However, on our new system, we now query JIRA for the projects, and given a selected project, then get out all the issue types and all the fields for those issue types. This means that there's only 2 requests to JIRA for us to be able to get out the issue metadata, and if the user changes issue types, we don't have to do a further request to JIRA. So now we've authenticated with JIRA and we've got this create issue form rendered on the client, how do we then create the issue after they filled out the information? So in beta, we were using XML RPC in order to create most of the issue. We then fill in some of the gaps in the XML RPC issue creation API using REST, such as labels. We would then use SOAP to be able to attach the screenshot that the user had taken within Bonfire to the issue. And this is a mess. We were using 3 APIs, 3 different requests to be able to create a single issue. And it didn't work on every instance. So if some of the fields that we couldn't get at using XML RPC were required on that JIRA instance, we were unable to create an issue on that JIRA instance. And that. So how do we deal with this? We moved to a custom REST resource because in JIRA 4.3 and 4.4 there was no REST resource available for us to be able to create an issue. So we wrote our own. The bad points is that there's extra code, but on the good side, we're now down to a single API that we have to deal with, so we no longer have to deal with XML RPC and SOAP, and we don't have to have XML RPC and SOAP client libraries within our JavaScript for the browser extension. And we're in control of that resource, so we can make it work on every instance that we can find, and we can add new Bonfire-specific features to this. So one great feature of REST compared to the XML RPC API is the ability to return far more useful error messages from JIRA when there are things that are going wrong. And this is excellent for us because we can then pull out those error messages and display them to the user, whereas before with XML RPC, if there was an error, we would have to parse this large document that was returned to us and try and find the errors within it, and then once we maybe found some errors, we'd pass them on to the user. So this sounds very familiar. So we had the same problem between issue metadata and issue creation, and we solved it using the same method, which was to write a custom REST resource. And this doesn't sound great, does it? Because if someone else has to try and do the same things that Bonfire is doing, they have to write the same code again, and we're not getting good reads here. So good news. In JIRA 5.0, neither of the custom REST resources that we had to write within JIRA would be required anymore. So the issue metadata and the issue creation REST resources are both available within JIRA 5.0. And once Bonfire can drop support for JIRA 4.3 and JIRA 4.4, we can move to those APIs and get rid of our custom code. So some takeaways from Bonfire's remote API experiences. The first takeaway is that you should be testing on real and/or complex data. So if we were testing on real data from day one, we wouldn't have hit the issues that we faced once we had released beta. When we did release beta, we were still on the XML RPC and the SOAP APIs, and we weren't able to create on all instances. However, had we tested on complex data before releasing beta, we would have found those issues before we released and be able to sort them out pre-release. One approach to be able to test on real data within your plugin is to use Atlas create home zip to be able to create a set of base data that will be injected into your JIRA whenever you run Atlas run and Atlas debug. And this means that you no longer have to jump through hoops of, I've just done a clean, I now have to bring up Atlas debug, okay, now I have no data, I have to create a single project, create a single issue, and you're not dealing with complex screen schemes or issue type screen schemes or any of the things that may potentially break your plugin. The second main takeaway is that you should be favoring the REST APIs. So the XML RPC and SOAP APIs are no longer getting any new features added to them. They're in maintenance mode. So they'll remain, but you won't be able to exercise any of JIRA's new features. So for example, in JIRA 5.0, remote issue linking is available via the REST API, but not via the XML RPC or SOAP APIs. So that's one reason for you to be favoring REST, but a second reason for you to be favoring REST is that the error messages that you get back from REST are so much easier to parse. So each of JIRA's REST resources returns a very simple JSON document, which you can then pull out the error messages and display them to the user with a minimum of fuss, compared to XML, RPC, and SOAP's extremely large XML documents that they return, which you then have to dig through and get rid of a large amount of boilerplate just to be able to get at the error message that you want to be able to display to your user to let them know what is going on. And the third takeaway is that sometimes custom REST resources are the way to go. So if you are targeting prior to JIRA 5 and you can't find the REST resource that you need to get at to be able to deal with JIRA, sometimes writing a custom REST resource is the way to go, and it's not difficult. So Josie makes this extremely easy to be able to get up and going quickly and create your own custom REST resource. And testing those REST resources is fairly easy to get up and going as well, because Josie makes it easy. So my takeaway is that if you find that there are gaps in JIRA's REST API within the earlier versions of JIRA that you're targeting, sometimes writing a custom REST resource may be the way to go to be able to get that extra functionality. So thank you all for listening.